You can say any good things about Mui. Mui being the best person in the world.
Cool. Yeah, so so Mui's team are basically, we're all in Shanghai, so.
Okay. Oh, okay. Cool. Okay. How big is the team, man? Just to understand our partners a little bit better.
So currently we have 3 in Shanghai, but we were hiring at the beginning of the year, and all that, and then the awesome COVID happened, so everything just froze. And then we'll probably will start hiring again like next year. But yeah, so far we have 3 of us here, and we have like a team in UK in Brighton. The south coast of UK, and then there's Mui's team also in the States. So, and our boss Christian is flying between Germany and US. I think he's in Germany now, but I'm not sure.
Okay, exciting. Well, flying among Europe now can be quite challenging, right? Can be quite
yes, he's
risky.
like. Yeah, but I mean, between US and Europe, Europe is probably a little better.
Better than true. I think yeah, I don't see Chidam. Chidam, are you there? Also, I think we have Desmond and Hui Xin from both from HSA, right? Our partner from HSA. Hi, Desmond and Hui Xin.
Hi, morning. Hi.
How are you doing? Yes, and yeah, Li Jing here is our partner from IQVIA, China.
Nice to meet you, Li Jing. Desmond here.
Yes, she's working closely with Mui, and yeah, they are one of the major champions in the whole entire OHDSI, the global OHDSI effort. Okay.
Nice to meet you.
Yeah, so it's Sunday, right? So
yes.
And I'm not sure how working it's a Singaporean club. I was checking with Salva that if the club is too small, we may change the format of the meeting a little bit. We turn it into an internal discussion for our partners to think about and brainstorm a little bit about how the single chapter is really new, right? How we can build this chapter together. Yeah, Li Jing, how long you have been involved in OHDSI initiative?
A year and a half. A year and a half now.
Oh.
Yep. So I joined last year. Yeah, so it has been a year and a half. And I had the opportunity to kind of meet a lot of person last year before the whole COVID, so it was nice. But then this year, it's like, we did get like, I don't know about Singapore, but in China, we still we're open, like domestically. So we did do some training in person this year, but I think a lot of in the first half of the year, a lot of things are just virtual. So, because this symposium was supposed to be in Shanghai, like what we're having now is supposed to be in Shanghai, and of course,
yeah, face-to-face symposium. Yeah, I know.
It was supposed to be in Shanghai. We have everybody will fly in and we'll have a good time, but I guess now we can still have a good time just virtually.
Sorry to put you on the spot, because you are the only one supportive enough to turn on your camera. So I'll keep talking to you.
Yeah, so I
mean the rest, if you may, I mean, and if it allows, it'd be great that you can turn on your camera. Like I say, we may not have a huge crowd today, given that it's a Sunday morning. So if you, hi, Desmond, nice to see you. But it's good for us to get together as a chapter, right? We are a very young chapter, to discuss among themselves, and also more importantly, I feel like we should learn from Li Jing on how we build the chapter moving forward. Hey, hello, Hui Xin. Yeah. Hi. Chidam, are you there?
Yeah.
Okay, cool. Yeah, Chidam is from. Oh, okay. Hi, Chidam, everyone. Yeah, we have
Srimane as well.
Yeah, Shimon, hi, good morning.
Yeah, hi, good morning. I'm sort of in between a few things. Camera will come on in a few minutes.
No problem, no, understand. So, and we have a few panelists from our Ministry of Health and of course Dr. Niam joining us later on, if no one else joins. But nevertheless, yeah, Li Jing, so since you kind of observe or work with many other chapters, right? Maybe you can share some, like say, sorry to put you on the spot, like right, impromptu. You probably didn't know that you need to do this. I'm just putting you on the spot, literally. I'll buy you drinks next time when I see you in Shanghai or Singapore. But I think everyone here is interested to learn that from all these chapters that you interact with, especially like Japan and Australia. They are quite young as well. So while they just build up, is there any tips we should learn from, or any pathway that we can follow for very young Singapore chapter?
Yeah, so so I think so I'm in so hi everyone. I think I don't know if I myself up before. I think we chatted yesterday as well. But yeah, so I'm in Shanghai, China. So I only joined IQVIA and then got into Odyssey basically for the job, and I think it's quite interesting. Definitely a nice journey for me, and especially kind of last year when I first joined, we had, when we still was. Pardon?
Sorry, Dr. Nam Kanok. Salva, can you? Yeah, sorry. Please go ahead.
Okay.
Sorry to interrupt.
I think it's definitely so I have already kind of worked with Selva a lot on the hypertension study. So it was, I think it's definitely I think Singapore has started at a very, very fast speed because we're also working with mainland, the China data partners on their data, and how to run the APAC hypertension study kind of simultaneously while working with Selva, because it's a lot of data partners together for the study. But I think definitely Singapore has already, like Alice is on, although I think Selva, we're still like the Alice version had a little issue, but I think that was okay. We got that resolved. So I think it's really, we have get off to a very good part of it. I think the next part is really kind of how to get more involved in like more studies. And I think it'll be nice for you guys to, if you have like a really good like topic or a study that that you can initiate and then have the other kind of APAC group to be participating. I think that will be the next kind of big steps, or like next big interesting project that people can work on, aside from joining the APAC hypertension study. If you guys have already had other like research interest going on, I think it's really, I think the other DIC partners will be more than happy to join as well, as the APAC community.
Great. Thanks.
So
Yeah, we have a new guest coming in.
Yeah. Hi.
Sorry,
Some problems logging in.
No problem. Okay. Yeah. Looks like we may turn this into our internal chapter meeting since it's Sunday morning, right? So we may not have a huge crowd joining us. So I changed the agenda a little bit. For our friends from HSA, have you guys already met Sriram from NUHS?
Oh, not yet. Yeah, we haven't met Sridham before, but we briefly met Selva. Yeah.
Okay. So maybe my bad. Maybe I think everyone knows Li Jing here from IQVIA China. Maybe besides Li Jing, let's do a very quick round of introduction in case the rest didn't know everyone, right? So maybe self. Okay, I'll start for myself. I'm Dr. Feng. You can just call me Morning here. I'm the co-founding chairs with Dr. Niam. And self. Sorry. Let me this Albert. Yeah.
Yeah, hi, morning. Hi, morning, sorry. So, yeah, welcome to the OHDSI Singapore chapter meeting. And together with Morning, we are co-founders of the Singapore chapter. So I'm Dr. Yang from NUHS, and we have adopted actually this OMOP CDM from last year, just that we only founded the chapter this year. So we spent some time mapping our entire hospitals and clusters data sets to OMOP CDM. And we have currently deployed Atlas on the NUHS site, internal site. So that is open and free for all our researchers to use. And we currently have over, I think, 80 different groups running different kinds of studies on internal subset of our data. And in terms of the mapping works, I think we've mapped pretty much everything except for perhaps the procedural codes. Our next phase of development, and Chidam can share some of it, is that we would like to map even free text data onto OMOP CDM. So this is an effort that we have taken almost a year and a half to undertake to map our free text into OMOP CDM concepts. Yeah, so I'm just going to hand over to maybe Chidam to make a quick introduction, and he can share with us some of the use cases.
Yeah. Okay. Good morning. I am Chidam from the GCTO office, Dr. Niam's office. So currently we are supporting research teams in the NUHS itself, and we are managing various databases in the GCTO office. Can I share my screens? Or,
oh, you want to make a formal presentation?
Yeah,
maybe let's do a quick round of introduction first. Then, although just among us, I think it's still a good idea for us to share our experience to let us know each other's work better. So after the introduction, then maybe we go by the program. I'll ask Salva to quickly do a 50 minutes and 20 minutes introduction of our work, and then followed by Chidam's, and then our HSA colleagues will come in as well.
I am from the GCTO office, NUHS, Dr. Niam's team. Currently, we are managing various databases and we are supporting research. So nearly 10 terabytes of data we are managing currently. And various teams, we are supporting the data, and we launch our local atlas. Later, I show you the screens, how it look like. Initially we started with 2 years of data, our NUHS data into the OMOP. Now is 4 years of data we have inside the atlas. So later I show you how our screens look like. Yeah, thanks.
Okay, cool. Maybe Salva, a quick introduction of yourself.
Okay. So hello everyone. So all of you might know me. So I'm Selva. I work under Prof. Morning as a research associate. So it's been like 1.5 years I've been into OMOP, we have like HSA, we have also done like EHR data transformation for a tertiary care hospital here in Singapore, KTPH. We have also deployed Atlas, and we have participated in a couple of network studies. Yeah, so that's it about my experience with OMOP and about myself. Yeah.
Great, thank you. Next, Desmond, maybe. Thank you.
Hi everyone, Desmond here. Hui Xin Shumani and I are part of the at HSA. We are part of this team called the Vigilance and Compliance Branch. So what we do is we mainly do post-marketing drug surveillance. So drugs that come out into the market, being used in the real world, we monitor the safety profiles and try to pick up signals along the way. Personally, I'm a pharmacist by training as well. So previously I was in NUH, but not sure if Dr. Niam's seen me before, but yeah. So right now only been in HSA for about a year and a half. Yeah, so pretty new to the team, also pretty new to the concept of OHDSI and OMOP. Yeah, but still learning a lot of things along the way. Yeah. Thank you.
Okay, nice to meet you, Desmond.
Thank
Next,
you.
let's have Hui Xin. Thank you.
Hi everyone, Hui Xin from HSA. So I work with Desmond.
Hui Xin, you are a bit soft.
Oh, okay. Can you hear me now? Hello?
Slightly better, but still fairly soft, yeah.
Oh, okay. Hi. I work with Desmond and Sri Mani on the same team at the Vigilance and Compliance branch. So we are also, we just started on OMOP maybe. We've been looking at it for a few years, but we started and converted the data, just completed converting the data maybe about 1-2 years back. Yeah, then we are also done a few studies on the treatment pathways, which we'll be talking about later.
Okay, nice to meet you. And Shimani, are you convenient to talk?
Yes. I hope you can. I've got my camera on. I don't know if you guys can see me, or it might be something to do with the settings, but I can't. If you can't, maybe I have to fix something. But now, good morning, everyone. Thank you so much for joining, taking the time to be here. It's nice to see this group of people working on the OMOP. On the OHDSI community growing in Singapore. I do see increasing interest among many people in this area, people from NUHS, the pharmacy department, MOH, and the different clusters as well. So that's kind of heartening. We, of course, come from HSA, and so we have a very drug safety sort of bias in terms of data analysis. We are preoccupied with trying to answer questions as to whether a certain drug is associated with a serious adverse reaction, because that's essentially our public health mandate to protect public health by ensuring that the safety of drugs that we approve is the benefits continue to outweigh the risk. So our work in this space will be trying to improve our surveillance efforts on medications, comparative efficacy wise. Yes, but sort of safety is our sort of primary interest in this space, and so that's one of the reasons why we've moved in this space. Following, it kind of seems weird, like why is a regulatory authority being so interested in this sort of research community? It's mainly taking reference from what the FDA has done in with their Sentinel initiative. The FDA several years ago came up with this Sentinel initiative. It's just sort of the starting point of where OMOP also came together, I guess, back in those years. And this was even before my time. So I only joined HSA about 3 years ago. And we have been trying to address our problems of sort of limited surveillance through our passive pharmacovigilance tools. And we're trying to make it a bit more active, trying to be a bit more ahead of the curve and trying to identify problematic drugs and take regulatory action as soon as we can to minimize harm. And so in that broad overview of what we are trying to do, we have been working on a couple of studies. So initially, just trying to get our hands wet with the OMOP CDM, trying to replicate some of the previous analysis, see whether they make sense or not in our data. Is there any visible trends or obvious interesting findings that we can find and all that. So we've done some of these things. Hui Xin and Desmond will be sharing some of these things a bit later. And then moving forward, we are looking at trying to make the OMOP CDM as well as the tools that are available within the community for drug safety analysis, specifically drug safety analysis. So there are some studies that we are trying to participate in as well, so the APAC study and so on. But we want to see if we can develop some specific tools that will be ready to answer very typical questions that we will always have, like how many people are taking a particular drug, how many people develop certain adverse event, and then identifying control group and looking at how many adverse events in that control group. These kind of questions are the same kind of questions that keep reappearing all the time, and it'll be nice if we have a tool that can quickly generate certain answers for us to see whether something is going on here, helps us in our investigations. So again, sorry to take so long, but I kind of felt that we should. I want to be a bit open and have a frank discussion here and see whether we can collaborate on certain things and work together and try to make this thing something that's useful for everyone. Thanks.
Okay, absolutely, no worries. Yeah, we all would like to learn what each others are working on, and like I say, the whole chapter here is to facilitate collaborations, right? That's the whole purpose. Yeah, and I also see I think Prof Yo has just logged in. Prof Yo, we're just doing a quick round of introduction of ourselves, or maybe you can introduce yourself to the team as well. Yeah. Hi.
Hi.
Good morning.
Hi. Good morning. I'm KKU. I'm a cardiologist from Heart Center. And also the DY GCMIO for research, and the OMOP journey is, I think we've just started, so I'm more here to learn and to see what the challenges are more than anything else. So thanks for having us, and then hope to learn more. Thanks.
Okay. Good morning, Prof Yo. Thank you. And also see a Sarah, but she's on hold. Sarah, can you hear us? Okay, I think never mind. So yeah, thanks everyone for joining us, like I say, on a Sunday morning. So let's just follow the agenda a little bit. The next item will be, like I mentioned, we will ask Selva from my team to introduce some of our work with critical hospitals and also our own NUS diabetes cohort, followed by Sridham from NUHS. We introduce some of the NUHS effort, while our colleagues from HSA will then follow up with their presentation as well. So without further ado, Selva, I'll hand over the mic to you. He's basically sitting next to me. Okay, Selva is all yours.
Hi, Selva, do you want to go to full screen?
Yeah. So through this presentation, I would like to talk about our experience of creating an OMOP CDM compliant database of type 2 diabetes patients from Singapore. So though most of the audience or almost all of you know what OMOP CDM is, so I'll not spend much time on this. It's basically a common data model to harmonize the heterogeneous data sources so that we can perform systematic and efficient research. So SGT2DM is a database which we created from the raw data from the KTPH hospital. So these are some of the data that we received from different domains. We received drug data, diagnosis, lab test, and vital signs. So and then we transformed it to a OMOP CDM form. And some of the steps that we did was date de-identification and standardizing the content, and then data format standardization as well. By content standardization, I mean transforming the local term representation to a universal standard common data model representation. Yeah. So and through that we have this type 2 diabetes patients cohort in Singapore, which is OMOP CDM compliant, and sample size is around 5,200 patients. So some of the tools that we used are listed here. So like again, USAGI is for vocabulary mapping. Vocabulary mapping, I mean like you want to map your source terms to the OMOP CDM terms. So it's impossible to do everything manually. So this USAGI is like kind of a semi-supervised tool which can kind of help you with some sort of finding textually similar terms. So that's for vocabulary mapping. And White Rabbit, we just though we had a better understanding of source data, we also experimented with White Rabbit to see how it does and how it performs, even if you want to use it for future for larger data sources. And then the ETL itself was done using Python and R, and then the databases like web API, OMOP CDM has a tool called Atlas, so which is a web interface to access the cohorts. So it has two components like web API and CDM. So those databases were deployed using PostgreSQL, and the whole setup is done using Docker. So this is just a quick thing about our tool set that we used. And once we transformed the data, we wanted to make sure are we losing any, we wanted to check whether are we losing too much of information by doing this transformation. But then looks like OMOP CDM vocabularies has an exhaustive coverage of terms. So we were able to map almost all of our terms, and the percentage of data that we lost was very small, like less significant. Yeah. And then those terms were also like very, they were like very rare terms. Not many patients had those terms as well. So the first table on the left hand side for me so shows about the information loss assessment, and on the right hand side you see like we have tried to assess the data quality of the transformation again through another method which is based on Khan's framework. So here it's just like multiple checks. Like for lab values we have certain the Khan's framework has certain set of rules configured. So no, we there is a R package available, so we use that and no, make sure just verify our data quality. And then yeah, so we have got 97% of the quality. And then when we inspected some of the issues, we were able to find that certain lab thresholds that they configured may not be applicable to Singapore, or the certain lab thresholds what they configured could be improved. Yeah, so those were the reasons why we have 97%. Yeah. That's about data quality assessment. And yeah, so again, most of you might know this. Like when we transform the data, we wanted to make sure whether everything is working fine. So one of the things that we did was we tried to reproduce a study which was already done by George and team. So here the plot that you see is called sunburst plot. This basically just tells you the treatment sequence, like what is the treatment sequence that patients had. So if you look at our data set, you can see that the major portion of our patients because they are type 2 diabetes, they started with metformin, and from metformin they have gone to metformin plus sitagliptin. Yeah, and the second major portion is glipizide and metformin. Yeah, so this just gives a simple plot visualization of treatment sequence that the patients in our data had. So yeah, so some of the contributions that we made to the community using our data source was, yeah, so we, to the best of our knowledge, I think we are the first one to transform the survey data, the questionnaire data to OMOP CDM. And yeah, that's one thing. And then we are currently working with UNSW on a phenotype validation study for type 2 diabetes patients. And then we have already published an EMEA poster on lab thresholds. Since now we have a lot of sites which are compliant with OMOP. So this lab threshold study is nothing but you get a list of lab measurements from all the sites. You get their measurement values like the 99% and the 100%, like what is the value, percentile values. And then through that, you arrive at a threshold, which is still going on, but that's the idea. So you, instead of like 100 clinicians or like 20, 30 clinicians sitting and coming up with the threshold values, we use data-driven approach to come up with threshold values. So that's the idea of that paper, which is currently in progress. But then, yeah, the poster was accepted in EMEA. So yeah, that's about the contributions that we made using this data set. And yeah, so this is just a demo, like if anyone is new here. Yeah, I'm just going to play this 2-3 minutes video, and might be I'll just walk you through while the video is playing. Yeah, there is no audio in the video itself, so I'm just going to talk. Yeah, so this just lets the different tables available in the OMOP CDM. So you can see that we have like almost all tables which can accommodate data from the hospital. Like we have care site. The concept is nothing but the vocabulary tables, and then we have table death to store patient death information, drug tables to store drug data, measurement to store lab data, and then notes, to store clinical notes, and then visit occurrence to store the visit types. Yeah, so that's the thing. And then here we will just show, though our data is de-identified, so there is nothing confidential. So we have de-identified all our data. So yeah, so you can just see that. Yeah, so we'll see what we have. Yeah, so here are person IDs and all are de-identified, and date of birth is also de-identified. So yeah, so if anyone wants to, like, if a newcomer wants to see how a person table looks like, you can see that we have concept IDs and fields for ethnicity, race, which can all be coded. Yeah, and what you're seeing on screen right now is the Atlas, a web UI which can help clinicians access the cohorts easily. So right now we are trying to show a graph of the drug exposure data from KTPH. You can see the drug information that we have. Yeah, so insulin looks like most of the person have insulin because ours is a diabetic cohort. And then this is another cohort within our institute NUHS. Yeah, so here you also get few summary statistics, distributions. Yeah, so here now through this thing, I'll show you like how we can create cohorts, like create inclusion exclusion criteria. Instead of writing SQL, clinicians can just use this web UI to configure the conditions. So they can just key in and then use the drop downs to select the different diagnoses or different conditions and different lab measurements or the age related things, etc. Yeah, or the observation periods if you want to look at it. And then since we have two sources configured, so you can just run it and you can just see the attrition report for the inclusion criteria. So DC is another source and KTPH is another source. Yeah. So you can just compare the comparison I'll show in another next short demo. But yeah, so this is the Atlas UI tool, which is like being widely used by the community for doing some quick summary statistics. And yeah, so the whole reason for standardizing this data, heterogeneous data sources is to help us perform efficient and systematic research, right? So now, so through that export option, you can export your code and share it with the other sites so they can just execute it. Yeah. So you don't have to do anything, just export that code. This just shows the results of the cohort that we created. Yeah, I think, there's okay, yeah, so that demo is done. Now I'll just show you how through our code, we can do a kind of a comparison between two cohorts, two sources as well. So this is just a simple comparison, but to help you understand how we have done it, you can just watch this video while I will also talk you through. Yeah, so I've installed some prerequisite packages, to run the, feature extraction and the, analysis. So first I established the connection to the databases. You can see the data sources are different. And then, so this, we are trying to extract HbA1c values from the database. So we are getting that data from the database using the existing packages, which is available in OHDSI. So so you use the covariate data package and get the data that you want, right? So you can see that I have used cohort ID 15 and I'm trying to extract the data from that. Yeah, this IDs that you see here are called as concept IDs. These IDs that I'm highlighted indicates the HbA1c IDs. And then you store, once you extract, you store them in that variable, and then you do a like R code to combine these two in a data frame, and then you just run some plot and you will see the visualization. Yeah, so this was a simple demo just to show you how we can do the analysis in a short span of time using already existing packages. And even if you want to develop your custom analysis, that is also easy. Or if you want to extract any other custom variables, it's easy to pre-configure in the OHDSI package and do it. Yeah. So that's it about the the presentation. Any questions? Yes.
Okay, thanks, Alpha. So
Yeah, I'll stop sharing.
Hi, Salva. This is Dr. Nyam.
Yeah, hi.
Yeah, hi. That was a great presentation. I just want to ask a question about your Atlas deployment. So I saw that you deploy on local host, right? So in KDPH, are the clinicians able to access this data?
No, not yet.
Okay.
Yeah.
So how do you plan to be able to expose the Atlas interface to your clinicians, or is it just for your researchers at this point?
Okay, it's for researching purpose at this point. For KTPH, we would be deploying at their site soon. Yeah.
Okay.
Yeah.
And in terms of your de-identification, this is the standard de-identification that you run, defined by the study investigators, is it?
Sorry, you wanted
for your,
to know?
Yeah, your de-identification standard, right? Meaning how you mask the dates, the age, and all that. That's defined by yourself or by the study principal investigators?
Okay. Yeah. So we came up with few approach and we discussed with them, and then they kind of we all agreed on one approach and we chose that approach to de-identify it. Yeah.
Okay. Thanks.
Yeah.
Yeah. So adding on about the de-identification process, because there are a few different strategies being practiced, commonly being practiced at the moment. So a lot of times, I would say is rather a executive decision than a technical one. Then after we discuss with the clinical PIs and they're comfortable that that level or that strategy or the identification is satisfied the purpose of the study and able to protect the any sensitive information of the patient, then we execute that plan. Yeah. Besides question, I think we would also like to welcome comments and suggestions, right? Since we are all here to learning from one another, from our colleagues from NUHS or HSA, who may have been in this journey even longer than us. So any comments or suggestions? Yeah.
Okay,
hi.
if I may, yeah, go ahead.
Yeah, Kofio, go ahead. Yeah.
Hey, hi. Trying to understand how do we so the data set is extracted from KDVH, packed with NUHS to analyze. So is it a continuous pool of data, and how does it differentiate from how does OMOP help this process? I still don't get the secret ingredient in this discussion. So if let's say because you're exploring data within KDPH dataset, how has it helped you? Is it because of the interaction with another center, or what is the benefit of using this particular CDM?
Okay, maybe Salva, I will take this one.
Okay.
Yeah, because the nature of the projects already require data integration from two institutes. So we have a diabetes cohort from Khoo Park Hospital. We also have a diabetes cohort from NUHS. Okay, although we have data from both ends, but you know that their default hospital electronic medical record systems are different. So the data coming out from these two institutes are different. So putting these two data together is a non-trivial task, right? The first challenge we made is what the common dictionary, right? So that we all know when we when we call it blood pressure, we all know the meaning of blood pressure, right? So and that's OMOP offers that. They offer a common dictionary to define thousands and thousands of clinical concepts. As it's so rich, right? It's really a rich dictionary. And second thing is, after you have the dictionary, and second thing is, what's the data schema, right? How do we store all this data? So OMOP proposed to store everything in about 24 tables, as Dalva shown just now, ranging from admission, medication, lab tests, etc. So they provide also a standard way to store this data. So given all this standard, and on top of that, the third thing will probably the alert web application allow physicians to quickly create cohorts or trial cohorts through a web page. So given this, now we allow the two institutes coming data sources from two places to be able to integrate a lot easier, because now we have standard practice. And that's exactly that's what we did, and what our demo is that after that integration, how we can now seamlessly query data from two institutes using the same platform. I hope that answers your question, Tokyo.
Okay, so yeah, thanks very much. That I think I understand a little bit better now. I missed part of that part where we integrate with NUHS data. So thanks very much. I have a ton of more questions, but probably too mundane. So I might discuss some of this offline with you guys at some point.
All right. Any suggestions from our HSA colleagues?
Yeah, hi, Silva. Very nice presentation. Thanks. Can you hear me well?
Yes.
Yeah. Okay. Yeah. So nice work on combining. You have essentially done a task that even though we have converted data into the OMOP CDM, we've never actually done the hard work of combining data from more than one data sources. So you've got NUH and you've got Kurekpat Hospital. So that's been for us. That is when we started, there was no other hospital that was converting or even interested in this business, and so we sort of went on our own track in some sense. And our job was more to explore on the tools, the availability of the tools, and the value that we could draw from having a CDM conversion. I kind of like your. I wonder if you can show us your you had this sort of overlapping histograms.
Yes.
HbA1c levels. Does that reveal anything to you, or maybe I don't know. For me, on a quick glance, it seemed like the KDPH people had a slightly higher HbA1c in general. Is that something that you shared with KDPH, or is that something that the clinicians took a look and saw that this actually does make sense? Our patients are a bit sicker. Maybe KDPH tends to see a bit more sicker patients in terms of diabetes control, and as a sort of referral center in that sense. Something like that. Has that sort of insight been used, or made sense, sense making done already?
So clinicians have also seen this from KTPH. So we have presented this to them as well. So they did have some idea after looking at the histograms. So though this was a very simple just HbA1c comparison, this may not be the everything they can use to come with the conclusion, right? But then this was just to demonstrate the use of OMOP CDM and the use of our tools to easily do the analysis. So this was a simple analysis to demo, but which clinicians also had a look, and then they felt it's good to know compare these two sources and find out. So that was the comment that they had.
Yeah. I think that sort of demonstrates the potential of looking for similarities or differences within hospitals. Different, even though Singapore is so small, I think that there are significant, noticeable, interesting differences among the different the hospitals and the clusters, and that sort of on a drug safety perspective, we always see something like this happening. We see clusters of things happening in KK Hospital. When we ask SGH and NUH, they say no, nothing really happening here. So something like this is nice to see, and hopefully this will spur more.
Actually, the another example could be that lab threshold thing, right? Like usually, like if you want to configure rules, instead of clinicians, of course, clinicians, 10 to 20 experts sit and come up with rules for each of the lab measurements. But now through OMOP, like you saw that like we had sites from USA, and then we had like Singapore, and then we had like APAC region, like other region sites as well. So all the data sites came together and they used a data-driven approach as well to go through the threshold for each lab measurement. So that was another an application which we also like really liked, and also got like some good comments from the EMEA poster as well. Yeah, so good feedback. Yeah, so we really understand the potential of the OMOP CDM and would love to collaborate and do a lot of research with institutes Singapore and across Singapore. So we should get it going. Yeah, let's get the ball rolling. Yeah.
Yeah, it's great.
Yeah. Any other questions or suggestions, comments?
Yeah, okay. Well, one more one that we always get. How much effort does it take to convert the data, and how long? What kind of help was rendered to you? And maybe just so we have our journey.
Okay.
That we'll share.
Okay.
Somewhat, and then it'll be nice to see how hear from you on this.
Okay. Yeah, so since our cohort is for 5,200 patients, since I kind of did most of the mapping, like cleaning and all those things, so like we had to review around I did not review, but I cleaned the data set. So I know that we had like the number of terms that we had to review for our data set was like around 8,000 to 9,000 terms, including drugs, diagnosis, measurements and everything. So which might be a very small number when compared to NUH or HSA itself. So we hired pharmacy. We are working with pharmacy students to review all these terms. So I would say for mapping it took around 2 to 3 weeks. And then ETL, we just did it in like 2 weeks. And then, so then we got it up. With Atlas installation, we encountered certain troubles and difficulties, but I wouldn't say that was like, that took a long time. So I think the whole thing was done within within 1 month, 1.5 months. But then we kept receiving improvements to the data or new data sources. So we just kept adding them in as they came in. Yeah. So for the map, I think the most important part or the concerning part for everyone would be the mapping resources that it takes. Yeah, so for our data set, which had around like 8,000 unique terms, it took around like 2 to 3 weeks. Yeah.
And just to clarify, right? Selva say 2 to 3 weeks. 2 to 3 weeks was for the initial launch, right? Everything like we still can launch something like within months, a few months. But then I think everyone in this will know that it's a very iterative process, right? Because you then later on figure out certain things need to be fixed. Certain new concepts wasn't initially mapped or mapped wrongly. Then we have to go back and iteratively fix it. In terms of manpower, just to give you an idea, besides Selva, we have 2 other research assistants helping along with Selva. And as Selva mentioned, we also hire some interns from our pharmacy department to help us to verify a lot of these terms semi-manually. Although we have some algorithm to automate the process up to about 80 to 90%, the last mile, we still need some, I would say, heavy manual inputs to refine it. And also when we participate in certain studies, then we notice like certain things are missing or certain things wasn't mapped properly. Again, we have to go back to optimize again. So Yeah, the initial effort probably 1 to 2 months to bring things up, but then to make it stabilize and everything, I would say a minimum 6 months or more realistic 1 year effort is a better estimation.
So can I just ask again a simple question? The data from Kutik-Puat, was it a continuous link, or is it just a static data set that maybe receives ad hoc infusions of data? I mean, or is the CDM layered on top of a data science platform within KTPH? I'm asking this because if the learnings from the mapping is not layered onto a platform within KTPH, it does suggest the possibility that if you have a different data set, or you wait a few years, you may have to revisit this. So I was just curious as to how do you all make the the interface or the rules that you have built more permanent. So NUHS, I know, has a very strong data science platform, but Kutik-Puat, I wasn't aware that they had one as well. So I was just curious as to how do you make the layering of the OMOP CDM more permanent?
So yeah, you're right. At the moment, all the mapping, everything is not live. So we are not yet. We do hope that in near future, these things can be integrated seamlessly and on a live manner. But as a very proof of concept phase or for research phase, currently is still a batch update. It's not a static. I would say don't say that it's perfectly static, but it's a batch update. So like every half year or 3 months, the new data will be ported from Kutik-Puat or our NUHS cohort to sort of the OHDSI OMOP platform. And the mapping, we have all the codes for the mapping to execute automatically. The subsequent efforts will be better because, as I mentioned, once we manage to correct or stabilize the concept mappings, a lot of things can be happen automatically. Of course, occasionally, then we will see new concepts popping up. Then we have to fix all those changes. Yeah, I hope that answers your question.
Yes, it does. And I was just thinking that, for those of us who are early in this journey, it'd be good to see something more durable in terms of the learning, so that we can, layer it on our own nascent platform. So we are trying to see whether we can extract some data sets and put on the cloud for collaborators, hopefully like yourselves, to work on, and then we can then layer it back into our data science platforms, which it's not ready yet, so to speak.
Okay. Yeah, with that, I think it's a perfect timing for me to introduce the next speaker, Chidam, to share the NUHS experience. Maybe then they will share more lights on how they do it, and then later on, our HSS colleague also will share that experience. Okay, should we? Yeah, Chidam.
Yeah. Okay. Okay. Good morning. My name is Chidam. I am from the GCTO office, Dr. Niam's office. Currently, we are managing various data sources, and also we are supporting the research teams in NUHS. So first, I am going to explain why we are using Atlas in the NUHS environment. So currently, we are supporting many research teams. Before going to the DSRB or IRB, the research team want to know what are all the data available in the database. For example, if they are going for a pneumonia study, the research team, they may ask how many patients are there in the pneumonia. So that time we need to look for the database, query the database manually and give the count to them. So the one is a very tedious process. To overcome this tedious process, so we introduce Atlas in the NUHS environment. So currently the Atlas is a web-based open source software developed by the ODC community. So currently our CDM is 5.3.0 and Atlas version is 2.7.0. So already Selva showed all the tables, what are all the tables inside the CDM. So the similar, and also we are using the Windows AD password control to access the Atlas. So we introduced the login mechanism inside the Atlas. So user can use their AD to log into the system, and also the account-based permission to view and modify the cohorts. So they can.
Sridham, do you want to full screen your presentation?
Yeah, it's already full screen.
Yeah, make a presentation.
So it's a account-based permission to view.
I think you mean sorry, Akina. I think he means presentation mode for your PowerPoint. So yeah, presentation mode.
At the bottom.
Okay. So is it clear?
Yeah, it's fine.
Yep.
Okay.
Yeah, better now. Thanks.
Yeah. So is currently we are using the Windows AD to log into the Atlas. It's an account-based permission to view and modify the cohorts. Example says the person A create a cohort, so the person B cannot edit the cohorts. And also I want to highlight our data CDM is not particular specific to the particular cohort. This one is ours is a full set of data source. So currently we have the 4 years of data. Initially we start with, as I mentioned, so initially we start with the 2 years of data first. Now we have the 4 years a complete set of data source. So the mainly includes patient demographic, visit, diagnosis, lab results, medication, and TOSP surgical procedures. It's already there. So the data from 2015 to 2018. So now, the data structure and what is the CDM, what is inside the CDM, already the Silva given some small introduction. Now I'm going to show our Atlas. So how the data presented in the Atlas, and also I'm going to take a small cohort study, type 2 diabetic mellitus with the age is 30. So the login is we are using this application is deployed in the NUHS intranet. So our users are using their Windows AD. So the URL is HTTPS Discovery AI Atlas. So you can log in using your AD. Log in, then you see the data source. So NUHS DM 2015 to 2018 is a 4 years of data. Datamart data is included in this Atlas CDM. So under the dashboard, you can see a lot of statistics information. What are all the data available inside the CDM? So I'm going to show all the screens one by one. So in the dashboard, you see the number of patients. So here, our dataset currently have 750.27K patients are there in the data source. And also you can see the year-wise, year of birth patients, the patients starting from 90202 to 2020. And also you can see the race statistics. And also under the condition occurrence, you can see the what are all the informations available, the statistics. For example, the essential hypertension. So we have the patients is 30,775 patients are there in the conditions. So like that, you can see all the condition occurrence report. And after that, the TOSP procedure, you can see the TOSP SM700 and nose endoscopy. So we have the 32,427 patients are there inside our data source. So all the statistics you can see, and if you want to know, if you want to download, you can download the statistics. So this one mainly used to the research team. Instead of asking us, they can see the information available in our data source, then they can start the research. So similarly, if you want to see the detailed drill down report, you can click any one of the items in the procedure or conditions. So here I showing the nose endoscopy drill down report. So here you see the age and the percentage of under 1,000 people. So here the blue color is male and the pink is the female. So we can see the even drill down reports. And also you can see the measurement report. So the measurement lab results. So here is a hemoglobin is we have 260,678 patients inside our measurement table. So these are all the information we can see under the data source. So now that's what I mentioned. So now I'm going to show my screen. I'm going to use the type 2 DM cohort with the patient ages above 30. So here there is within the atlas we have the search option. So you can search whatever you want. So currently I'm searching type 2 DM. So here I can see all the type 2 DM. So this one you can see the number of records exist in our data source. This one similar as Athena. So you can see all the available informations. Currently I'm searching type 2 DM. So you can see all the type 2 DM informations in the details in the search page. Next, how I am creating a cohort, I'm going to show. Before creating the cohort, I am creating the concept set. So the concept set, I'm going to create type 2 DM concept set. So here, within the concept set, I am going to include more than one concept. So I am creating the concept set type 2 DM. So here I'm including all the type 2 DM related concept as one concept set. So this one is my concept set. I am going to use this concept set within the cohort. So now I am creating the cohort called type 2 DM. So within this cohort, so I am adding the condition occurrence is just now I created the concept set type 2 DM concept set, and also I'm including one more inclusion criteria, says age criteria is above 30. So once I create, I save the information. Then after that, I run the report. So here, this is the reports from the atlas. So here it shows that total number of patients is 20,708. It's a type 2 DM patients. Out of that, the age above 30, you can see 20,350 patients are there. So this is the report we can see the cohort. So here after that, next I am moving to the cohort characterization. So under the characterization, we can see the more detail about the cohort. Last time in the cohort creation and report, we saw how many patients are there in the above age 30. Here the characterization, you see the here I add the cohort is a type 2 DM, and I include the feature analysis. Maybe I add the demographic gender. So once I add and run the report, I will see the report like this. So last time I see how many patients are there in the age above 30. Now I can see the patients, female, how many female, male, how many female, how many males. So the count I can see under the characterization. Next one is the cohort pathway. Cohort pathway is an aggregated sequence of transition between the event and target cohort. So in the target cohort portions, I select, last time I created the cohort type 2 DM, and also I am selecting the event cohort. This one I created already. So these cohorts are diabetic medicines cohort, example insulin, metformin, all the cohorts I created. I select this one as an event cohort. After saving this one, if I run the report, I can see something like sunburst diagrams. So here I select, you can see the details. So the patient, this patient start with insulin, and next we go to the metformin. Like that you can see the sunburst diagram, what are all the drugs they used under the pathway. So the next one is the incident rate. Incident rate is something like we can see the based on the target cohort how many outcomes. So here I select the type 2 diabetic mellitus as my target cohort, and I'm using the kidney disease is my outcome cohort. So kidney disease I created already under the cohort definition. So once I run the report, so I can see the out of 15,349, 1,204 cases have the kidney disease. So this is the information we can see the incident rates. And apart from this, it's a profile function in the Atlas. Here you can see the individual profiles. So already de-identify data. So just we can see you can de-identify the person ID, and you will see the details of the whole profile, how many drugs, conditions, visit detail, everything you can see the persons. Apart from all these, we can do the prediction also using the Atlas. So the prediction modeling, yeah, I'm going to use this. My target is type 2 diabetes cohort, and my outcome is kidney disease. Already in the Atlas itself, there is a predefined models. So lasso regression, random forest, decision tree, also is a predefined models are there. So currently I'm selecting random forest and lasso logic regression settings. After setting all these, and we need to set the covariates for this cohort. For this prediction modeling. After that, we need to download this. So within the Atlas, you cannot run the prediction. So you need to download the package, and you using the R environment, you need to run this package. So currently I am downloading this package. After that, the package look like this. Once you extract as a zip file, once you start downloading, it will shows it will download as a R package. Once you extract, you will see the package something like this. So using R Studio, you open this test.R project. So once you open this one, you need to give your database settings here. So what database you are using, and user ID, password, and the server detail, port number, everything. After that, before that, you need to deploy all the PLP related package, patient level prediction packages within the server. So after deploying all the PLP packages, you need to run this R program. It will run, and you will see the result something like this. Under the PLP viewer, you can see what are all the model you are running, and you can see roughly you will see the result under the PLP viewer. So what is the model setting? What is the population settings? So yeah, that's all about my presentations. So just I want to show how our Atlas look like, and how much data we are using in the Atlas. That's all. Thanks.
Thank you, Chidam.
Thanks, Chidam. We'll just invite some comments from what Chidam has just shown first.
Can I just check? Do the users use it themselves, the clinicians, investigators, or do they have to work with data scientists to perform the analysis?
Okay, this one is the research team. First of all, the research team, they can log in using their Windows ADID if they are using the NUHS environment. So they can log in and see the available data in the Atlas, and also they can do their own cohort and try the thing before they are doing the research. This one is mainly for the exploratory analysis. So if they have any plan, so they can create their own cohort, and also they can do the prediction modeling within the Atlas itself, and they can see the outcome roughly before they are submitting and before doing the research.
Yeah. So I can add to that point, KK, which is the vast majority of the users today on NUHS Atlas are clinicians, because the idea here is to make it easy for them to run the query on those data sets. And I just want to emphasize that this entire data set is on a standing database IRB. So none of the researchers who want to do this exploratory analysis on Atlas require a project-specific IRB. So as Chidam mentioned, it's only after they have done this exploratory analysis and they want to go in depth and do some specialized analytics that they need to get their institution-specific IRBs to be able to explore the data. So typically, we don't extract the data for them until they have done some form of cohort building and preliminary analysis of their cohort using the Atlas.
Okay, thank you.
Yeah, any questions from anyone else?
Hi, Hui Xin here. Thanks very much for the presentation. I think it was interesting. Just want to check with you, for the programs to run on R, do you encounter any issues with like the amount of data that you have to work with? Like, is the hardware, in terms of hardware, was it okay? Did it run smoothly, or any like issues?
Yeah, currently, okay. Currently, as I mentioned, we introduced 2 years of data initially. After that, as I mentioned, now we have the 4 years of data and also the 750K patients. The software, the whole deployment within our system name is called Discovery AI. So this one is the protected data cloud environment. So we deployed within the PDC. So we don't have any much issue like deployment in the sense the cloud is a more feature like scalability, as you know. So yeah, that's what initially we go with some setting. If the data volume increase, then we increase the RAM and we increase the storage. And so far we have the 90 users using our Atlas in the NUHS. So we don't face any problem like this kind of lagging and slowness. Yeah.
Yeah, again, to add to that point, I think Hui Xin is referring to running the R package when you have already extracted it. Is that right, Hui Xin?
Yeah.
The one is.
Yeah, go
okay.
ahead, Chidam.
No, Dr. You can proceed.
Yeah, so there are two ways of running it. One is that the extracted package is then run separately on a separate on a virtual machine with the sufficient resources to run that package on the data set. So typically we have R server to run this, and we don't have problems because we don't have so many R packages running. From about last year, we actually tried to automate this process, but there were some difficulties. I mean, I'll be upfront, we tried very hard to automate the process where we allow users to extract the R package, and then we wanted it to run in an automated way. But there are some issues with the way Atlas was coded, the OMOP is coded, such that it doesn't avail itself easily to run these R packages in automated fashion. Am I right, Chida?
Yeah.
Yeah.
Still we are working on that. Yeah, we are facing some problem. So currently we are helping them to run manually. So once they download the package, once everything, the cohort, and initially if they want to do any exploratory analysis, they will create the cohort and see. Once they see the results, and they will see the counts based on the inclusion criteria. So once they are satisfied, then they are creating the predictive modeling. They can select the existing models like lasso regression or random forest, whatever. Then once they selected everything, save successfully, then they download the R packages. Then we help them to run in the server side. Currently, we are doing like that.
Okay, thank you very much. Yeah, I think that is a very good idea. Yeah, because we can provide the support for the R packages also.
Yeah, we don't want to provide stick client kind of support because everything should be run on the background, on the back end on the server. Yeah. Any other questions from the rest of the participants?
Yeah. Hi, Dr. Niam. Hi,
Yeah.
Chidam. Yeah. So
Hi.
I understand Chidam mentioned that Atlas is mainly for exploratory data analysis, just to identify cohorts, and then the clinicians will decide after that whether do they want to proceed on with the studies, right? So I was just wondering, are there any, let's say if a clinician finds a particular cohort that he's interested in, he wants to do a prospective design to study the cohort longitudinally, is there any way to re-identify this cohort or any processes in place to re-identify them?
Okay, maybe I can take that question. So in NUHS, we have processes to re-identify patients. We honestly, I can share with you that we've never needed to invoke that because of two reasons. First reason is almost the entire data set is de-identified. So reason why you want to re-identify the patient, unless, like you said, you want to do a prospective study. Typically, most researchers don't come into the study and say that, okay, I'm going to find 5,000 patients, identify them, and then start following them up from in the mid study, right? Because you need to apply some kind of study protocol, and it doesn't make sense to start a study protocol midway through an observation. So typically, if they identify cohorts, right, then they say, okay, we find that there are sufficient numbers of such patients for us to do a prospective study. Then they start a fresh prospective study. So they never actually needed to re-identify the patient. So very rarely we do get requests for re-identification for various reasons, and typically not for research reasons, things like audit and things like that. So this goes through a multi-stage process, and it's very, I'm going to say it 3 times, very, very, very closely guarded. Okay, it's not easy for you to re-identify a patient. You have to apply, you have to put a non-exam IRB in. The institution data governance committee need to review it. The data protection officer need to review it. Only if you pass all that, then we would send the cohort that needs re-identification to the key holder. In fact, we don't hold the keys, right? Somebody else holds the keys. So we got to send it to them, and then they re-identify. And then all we can say is good luck with what you do after that, because identifiable data in an institutional context for us is like toxic nuclear waste. You have to find some way of holding it, right? Because it's identifiable and it has to be safeguarded with many, many layers. So right now, I don't think that there are people who have compliant systems that can host research-grade identifiable data. I'm not saying anything bad about others. There are a lot of non-compliant systems that host identifiable data. There's always that risk there, okay? And from a audit perspective, that's always a major issue. And just want to mention that our current system was just recently audited by GIA, and they also found, despite all the audits, they still found 1 or 2 things that they said about it, right, Chidam?
Yeah.
Yeah.
Okay, thanks a lot. Thanks for clarifying.
Yeah. Any other comments?
Yeah, if I may, just a quick one. This is Srimani from HSA. Siram, nice presentation. It's very nice to see how you guys set up Atlas. If I didn't hear wrongly, you had interest or already had some things going on with the unstructured data, putting it into OMOP CDM. Just asking whether did you have? Yeah, I just wanted to know whether you've got any way to use Atlas to sort of interact with that unstructured data, maybe search for certain keywords present in discharge summaries, for example. Have you got something like that, or any plans to do something like that in that space?
Okay. Currently, yeah, we implemented only the structured data. Currently, we are working for the kind of discharge summary, and yeah, we are working for the CDOC data. The one not yet ready, so we are planning for that. So within the discharge summary or doctor note or nurse note, whatever, so we search for the particular terms, and we use the Usaki tool to map the term, and we identify the term belongs to which domain. Based on the domain, we are uploading the data into the CDM. So currently we are working on that. Yeah.
Okay, I can add to that. So just to mention how we do it. So it's all the text in our EMR system. So it includes, like Chida mentioned, discharge summaries, clinical notes, physiotherapy notes, basically anything that's a text, right? So what we did first was to undertake a tokenization, parsing, then embedding of all these texts. We have already spent, I think, close to 1.5 years just to get that particular model right. We're using a encoder decoder methodology. It's a kind of NLP tool published by Google. It's called BERT, to pick up the correct terminologies. Then after that, we've done some validation to ensure that the terminologies that are picked up are appropriate. And typically most NLP tools end at this step, meaning after you've done you applied the BERT and then you got a whole list of terms, right? That's where you end. So the other thing that we've done, which Chidam has just mentioned, is to take those terms and use Usagi and map them to OMOP CDM based on diagnosis, investigations, management, and medications. As you can imagine, this process is very, very laborious because we're talking about, I would say, tens of millions of concepts. So what we had to do was to then rank them and then fit them properly so that they are appropriate terms that map appropriately to OMOP CDM. So, for example, we had to, of course, remove things like negative statements, ambiguous statements. We had to deal with, the usual, the abbreviations and all these things. So these are all standard stuff. Now, on top of that, you add some of the more manual kind of curation that allows us to pick up clinically relevant terms that matter to our researchers, right? So we have gone past that step, and then now we are just basically reducing the size of that database because it's just ginormous terabyte size databases that have many terms. So right now I'm just curating some of these terms so that the kind of useless terms are not appearing there. So things like words like study or evaluation, these all are mappable, but they're not useful. So we have to remove them. And as you can imagine, this is a slightly subjective exercise, right? It really depends on what people might deem to be useful or not useful. And then finally, Chidam is working on it to see how we can then use the Atlas interface for people to search for these terms, as well as to put up some example terms that example notes that come from those particular notes that you identify those variables. Yeah, so that's the whole process. It's quite long-winded.
Okay, thanks. Very useful. Yeah.
Okay, so with that, should we move on to our last presentation before our panel discussion? Okay, so I guess Desmond, you'll be presenting.
Yeah, just let me share my screen first.
Okay, cool. Good. Over to you, Desmond.
Okay, thank you. Thanks, Mom. Can you all see the full screen?
Yep.
Okay, yeah, so thanks everyone for giving us the opportunity to share what HSA has done so far in terms of the OMOP CDM. Like I mentioned at the start, Hui Xing and I are both, we are part of the data analytics team in the vigilance and compliance branch at HSA. And what we mainly do there is we're looking at drugs after they have been released into the market for use in the general population. We're looking at safety signals and adverse events from these drugs. So how I'll be running through this, I guess Srimani at the start already gave a very good overview of what we do and why we do. I'll just make an attempt to tap on a little bit more on why we need surveillance, drug safety surveillance. And there's this big term that's called pharmacovigilance. Essentially, it means the same thing. I'll briefly touch upon what HSA has been doing in terms of our spontaneous reporting system and how we plan to use EMR to move forward into a more active form of surveillance. Yeah, Hui Xing will be helping to run through the process on how we converted to the CDM as well as the methodology that we employed. And then I'll come back later to just briefly discuss the results for everyone's sharing as well. So feel free to stop me along anywhere along the presentation if you have any questions, or I can take questions at the end as well. Okay, so the whole idea behind pharmacovigilance is First of all, we have to understand how a drug is, the entire drug development process. So if you look at the picture at the bottom of the screen, typically a drug from bench all the way to it hits the bedside typically takes up to 10 to 15 years. So it goes through multiple iterations of animal studies, human safety studies in phase 1, followed by safety and dose efficacy studies in phase 2 onwards, as well as in a larger population of about thousands of people in phase 3. However, that being said, despite all these efforts, we do know that there will be rare and unexpected events that may or may not be identified in the trials. And that's why at HSA, we want to pick up the possibility of these events happening in the larger population. Yeah, especially in some of the higher risk groups, like your elderly, your very young, the pregnant ladies. These are the populations that are probably more susceptible to certain events as well. And in most clinical trials, in the typical setting, these populations will not be included as part of the trial studies. Yeah. We're also looking at things like long-term effects, because if you look at the typical timeline, it's about 10 to 15 years. A typical follow-up for a study population could be anywhere between 3 to 5 years. But sometimes certain adverse events do occur only slightly later down the patient journey, maybe even up to 10 years. And this is what we're hoping to be able to pick up through pharmacovigilance. Likewise, there definitely will be safety events that are picked up during the clinical trials. Those are what we call the expected events. Even though we do know that these events definitely or have a high probability to occur, we also want to be able to pick up if, let's say, there's an increased frequency or severity of these known events. So in a sense, if we pick up new signals of already well-determined events, but we found that maybe in a certain particular patient population is the event rates are going up, that's where HSA will want to step in and perform regulatory actions on the drug if necessary. So if you look at the bottom left, the yellow form, that's traditionally how our spontaneous voluntary reports have been sent into the HSA. So in the past, doctors fill up the form, they either fax it or post it or email it to us. And then on our end, there'll be a team that looks at these reports, analyzes the reports, and then we look at it as a whole to see across different hospitals, do the same reports pop up, are the same drugs having similar adverse events, and so on. Yeah, from 2006, we actually have CMIS, Critical Medical Information Store. It's a system that was set up in a majority of the public hospitals in order to allow doctors and other reporters to actually key in these adverse event reports through an online form. So that's the system that you see at the bottom right there. It's quite a lengthy form. I understand there are many fields, but most of the times doctors fill in just the critical information. And right now we receive about 20,000 reports annually. Yeah, there are limitations with this form of spontaneous reporting systems. One of it, the key thing will be underreporting. So underreporting is actually a very typical problem across all spontaneous reporting systems. In some studies, it's shown that it can be as high as up to 90% that's underreported. And many of the times, another issue that we face is stimulated reporting. So reporting that comes in after certain events, like the most recently, I think most of us might know that the incident of the flu vaccines in Korea, that probably might have stimulated some kind of reporting as well. Yeah. Another issue with spontaneous reporting systems is that most of the times it only captures very basic information. So we only know what drug is involved, what event is involved. Sometimes some reporters do give us the onset dates. They give us some things like latency, time to recovery, and so on. But we often miss out information like in terms of drug dosages, how long has the drug been used, was the drug used with any other medications that might lead to adverse events. And more importantly, we also miss out a lot on the patient's medical history, social history, as well as any other social factors that may contribute to the adverse event as well. Yeah. And because of this lack of data on the drug usage, it's typically very hard for us at HSA to really calculate incidence rates and in terms of looking at the entire safety profile of the drug. So that's why there is this movement, especially like what Sri Pani mentioned, FDA is moving on with the Sentinel initiative. So we are sort of trying to mirror that as well, to really move from a passive reporting program into an active surveillance system. But that being said, it's not that we are replacing it with a new system, but rather the two systems have to come hand in hand and augment each other so that we have both active and passive sources of information. So with that, I'll hand over to Hui Xin first. She'll run through how we design this CDM conversion, as well as how we the process behind looking at the data and then the insights that we've done so far. Over to you, Hui Xin.
Oh, Hui Xin, I think you need to. You forgot to unmute your.
Okay, sorry. Now?
Yeah, can hear you.
Loud and clear.
Okay, thanks. So yeah, I'll just run through our process of this study where we wanted to actually try out the CDM, especially the OMOP Common Data Model, in order to harmonize electronic medical records and gain more insights on our drug safety surveillance. So in this project, we try to transform data from an acute care hospital in Singapore to the CDM developed by OMOP. And then after it was transformed, we try to apply the analytical tools on the data to profile treatment patterns of patients who were newly diagnosed with diabetes, hypertension, or depression. Okay, next slide, please. Okay, so a methodology consisted of two parts, which links back to our aim just now, which is first is to convert the source data files to the OMOP CDM. And after it's been converted, because there's been a similar query that has been done to evaluate the treatment pathways previously, we actually modify it to our converted, to apply it to our converted CDM data. Next slide. Okay, so more about our data source. We got this data from a tertiary care hospital in Singapore with approximately 250,000 patients from January 2013 to December 2016. So that's about 4 years of data with 1.1 million rows of diagnosis, 5.2 million rows of ordered medications, and 15.5 million lab records. Yeah. Next slide, please. Okay. So this is our process of converting to the OMOP CDM. Just very briefly go through like what was the thought process behind it. So in OMOP, there's this data vocabularies, especially for standard vocabularies such as SNOMED CT, RX norm, and LOIN. They are assigned to different domains such as SNOMED CT to diagnosis codes, RX norm for drugs, and then LOIN for laboratory tests. So our process is summed up in the diagram below, right? So our source tables has the concepts such as diagnosis, drugs, and labs. So the first thing to do is like we see whether it is in the OMOP vocabulary. So like for example, if it's actually already in one of the vocabularies such as ICD codes, then there's a mapping to the standardized vocabulary that's provided by the OMOP into SNOMED CT, and from there we can get the OMOP concept ID. But in some cases, if let's say it's already written in like for this drug amoxicillin clavulanic acid, it's not in any vocabulary, it's just the drug ingredient name, then we had to trace back to the original prescription order to get the full name of the drug itself, and then manually map it to the standardized vocabulary of the inside RX norms, such as amoxicillin 500 mg clavulanic 125 mg oral tablet. And then this has a corresponding concept ID. So there are both automated and manual processes in our conversion of the source data. Yeah, next slide. So overall, this is the percentage of records converted. On the left, you can see those are the OMOP CDM version 5 tables, and on the right was the source tables that was given to us by the hospital. So every table inside the OMOP CDM had some corresponding tables in the source data that we could use to map over. For example, the primary and secondary diagnosis over to condition occurrence, lab results over to measurements, yeah, and this prescriptions as well as medication order over to the drug exposure. And the proportion migrated was above 90 for most of them, except for drug exposure, but this was because the drugs data itself also had information like syringes and food. So for those, we did not map them over to the drug exposure table. Yeah, next slide. Okay, so after the data was converted to OMOP CDM, then we actually did a modified query on the transform data. And this modified query came from an earlier study that was done by the OMOP community to evaluate the treatment pathways of patients who were newly diagnosed with diabetes, hypertension, and depression. So what we did first is shown in this diagram, which is to establish the inclusion criteria for the cohorts of interest. So for this cohorts in particular, their entry into the cohort was defined by the first exposure to any drug of diabetes, hypertension, or depression. And then we also had a condition that they will have at least 6 months of prior observation. So they had to be in the database for at least 6 months and at least 3 months of observation post-exposure. And no exposure to the drugs of interest for 6 months prior to index exposure, and at least 1 drug exposure after index to ensure that they were actually continually receiving these medications. And then also we had to have the condition occurrence of the disease of interest for at least in any time occurring 6 months before or 3 months after the index exposure, and also to exclude any diseases within that time period as well. Okay, next slide, please. Yeah, so this is more information on the inclusion and exclusion criteria for the different cohorts, 3 different cohorts. So the disease of interest would be diabetes, hypertension, and also depression for each of these cohort. And for excluded diseases were actually findings related to pregnancy, and an additional one for bipolar disorder or schizophrenia for the depression cohort. And for the drugs classes included, for diabetes, we had insulins, biguanides, sulfonylureas, DPP4 inhibitors, alpha-glucosidase inhibitors, and SGLT2 inhibitors. Hypertension includes antihypertensive, diuretics, peripheral vasodilators, beta blockers, calcium channel blockers, and agents acting on the renin, angiotensin, aldosterone system. And for depression, is all drugs falling into the antidepressant drug class. Yeah, next slide, please. Okay, so,
Hui Xing, do you want me to take over from here?
yeah.
Okay. Yeah, so I'll just run through the results as well as some of the charts that we made through the cohorts as well. So from the 3 cohorts that Hui Xing mentioned, after including and after applying the inclusion and exclusion criteria, for the diabetes mellitus cohort, we got 1,006 patients. For hypertension, it was about 3,175 patients, and depression only about 251 patients. So, so what we did, similar to I think the work of Selva and Shidam, we also looked at the treatment pathways in which these patients took and plotted them on sunburst diagrams. So I'll just run through each of the conditions briefly. This was the sunburst diagram that we generated for diabetes. Total cohort was of 1,006 patients. What we found was that the yellow inner ring, which is metformin, was the majority of the patients, about 53.5%. After that would be mostly sulfonylureas in terms of the next layer of the ring, where you can see glipizide, which is the light blue ones, and as well as glycoside as well, the darker blue ones. Yeah. So among sulfonylureas, glipizide was the most common, followed by tolbutamide. Some of the newer agents like glycoside, glimepiride, we didn't see them as often used, probably also because of the period of the data, where it was from 2013 to 2016, where these drugs weren't as commonly prescribed as currently now. Yeah. So what we did was we went one step further to look at the HbA1c values, just to try to get a sensing of what we could do with the data. So if you look at the very busy chart on the right, what we were trying to do is we're just trying to compare 4 different cohorts, users that were on insulin alone, those that were from insulins who were subsequently swapped to OHGAs, all your oral hypoglycemic agents, so like metformin, sulfonylureas, and so on. Those who are on the OHGAs alone, as well as those who are on OHGAs initially and then subsequently swapped to insulin. So from there, we tracked up to the first 4 readings of the HbA1c. Typically, the duration between readings was about 3.2 months, which is quite expected because typically A1c values are measured every 3 months to get an average indication of how their sugar control was like the past 3 months. So interestingly, what we observed is that if you look at both the initial insulin cohorts, which is the purple ones and the orange ones, we can see that generally you can't really tell whether the values are uptrending or downtrending. They're hovering around the 8 region. But if you look at the OHGA, those who started with oral ones, followed by the light blue ones where they started with oral and then move on to insulin, right? Generally, you can see that there is some downtrending from a low 9 to a near 8. So some of the interesting observations that we've seen, but then again, that being said, we can't really tell for sure if this is a good indication of control as well, because there are many other factors that we can't really attribute to. We need to find out more in terms of what other concurrent medications they were on, what's the level of care that these patients were given, did they have more follow-up visits versus another group. So this is just a quick view of trying to get a rough idea of what converting to CDM can do for us. Yeah. So next I'll move on to the hypertension cohort. So for hypertension, generally a majority of the first-line users were using amlodipine, calcium channel blocker, so about 22%. Among that, the other drugs were quite fairly mixed around, quite a proportion on atenolol, a few on enalapril, some on losartan. So we found that there were quite considerable heterogeneity among the first-line treatments for hypertension. And then for the second-line options, most of them were actually the ACE inhibitors and the ARBs, as well as the calcium channel blockers. So enalapril, losartan, nifedipine, and amlodipine. So like Hui Xin said, we actually modeled our study after the study published by George and Patrick in 2016. In their study, they found that the most prevalent drugs were hydrochlorothiazide, lisinopril, and amlodipine. In our study, it was slightly different. We had amlodipine as well as enalapril, which is also another ACE inhibitor, but we found that there were very few diuretics found in our study. One postulation we probably we thought of was it could be because in 2014 the newer hypertension guidelines came out. That was the JNC 8 guidelines, where there was a push towards using more ACE inhibitors and ARBs like losartan. So that could possibly drive the prescribing patterns as well. Lastly, for depression, depression was something that, because our cohort wasn't very big, it was only about 250 patients, but yet we found that there was a very large heterogeneity across all lines, whether it's first line, second line, or third line treatments. But the majority of users actually were using mirtazapine and fluvoxamine. What we also found was that there were patients that actually used up to 4 to 5 drugs actually. So it also goes to show that for depression, probably in terms of the treatment options, because of the varied number of treatment options, clinicians tend to have a bit more flexibility to adjust regimens based on patients' responses and as well as in terms of clinical presentation. So in general, in terms of sunburst diagrams, we found that some of the things that we couldn't find from the sunburst diagrams are things like dosages and dosing frequencies. So all we knew was the order in which they were prescribed, but we were not sure why certain treatments were stopped or switched, and we couldn't really elucidate the reasons for that as well. So this is generally something that sunburst diagrams can't demonstrate. But overall, through the entire conversion to CDM process, we found that using these federated queries, it could give us some valuable insights in terms of what the drug utilization patterns, as well as the treatment pathways from these different drug cohorts. Yeah, and the last point would be like what I mentioned in terms of the data sets that we had for all three cohorts. We found that there was quite a bit of heterogeneity in all the treatment patterns for hypertension and depression especially. But for diabetes, we found that metformin was the most common first-line agent. Yeah. So that'll be all from us. We're happy to take questions.
Hi, hey, thanks for sharing that. And can I just ask, how long did you all take to do this whole process from mapping to analysis, and with how many team members? I'm asking this just to get a sense of the resources required.
Okay. I think I'll let Hui Xing answer that.
You're muted, I think.
Okay, yeah, I'll take that question. So for the mapping itself, we had an intern who was with us, and then he took about 3 months to do the mapping and conversion on the SQL database. So he wrote all the scripts to convert each of the tables into the OMOP CDM tables. Then for the analysis itself, because it was already written by the one of our, George and et al. From the OMOP community. So basically it was maybe to download and to modify it and try different combinations of inclusion and exclusion criteria that took about 1 week or so. But subsequently, when we sort of did a second round of CDM conversion to make sure that all our data was correctly mapped over, I think that took another 2 or 3 months for us to refresh the treatment pathways graph.
So all in all, maybe about half a year. Can I ask, this is a really stupid question, because how do you all know that the mapping is correct? I mean, is there an external validator of some, error message that, hey, you guys missed this, or this wasn't done perfectly? How do we know? I'm just more curious than anything.
Yeah, maybe Hui Xing, you wanna maybe I can add on something, and Hui Xing, you can chip in as well. So yeah, this is of course the anxiety that we also had lah. Are we actually looking at the right data? Once we convert, do we change anything that the CDM just changes the form of the data, but the substance shouldn't change, right? We don't want to mess around with it. So we did a few HSA, we're very conservative. We worry that we make a lot of mistakes because we have very low threshold for making mistakes. So we did a few, this is what we did. We took a sample of the converted data, and we looked at it, manually go back and see, for each of these rows, what were the original source data values, just to, make sure that we are doing it right. And we did, in fact, find mistakes. And I think that is something that we probably, I think Morning also alluded to this earlier. The conversion initially, so we had this guy, a very brilliant Yale NUHS student, was an expert in, not really an expert, he was familiar with SQL. So that's another skill set that is essential for anyone who's doing this conversion. Some domain knowledge combined with a good understanding of databases and recreating the schema into the OMOP CDM. This student had took about 3 months, but then we did further validations along the way, and then we realized, hey, we actually, for example, the diagnosis table, somehow the ICD codes had no decimal points. When we got the data, they somewhere along the way these things got dropped, and then we had to go and figure out where to put the decimal point. These were 3-digit numbers. Sometimes they were 2 digits. If it's 2 digits, I guess you put it right in between. But 3 digits, then you got to go and be quite careful. So we did a lot of manual work. This was a lot of hard work, manually looking through. Who did this? The pharmacist. So HSA has got the vigilance branch has a number of pharmacists, and they basically poured through the data to check whether any of these were wrong. And we did find some errors. We go back, we fix them. We do another sample again. I think that time we just took a handful, about 100 records. That was what we could manage. And then we did it again, just to check. So those were the sort of sanity checks that we did along the way. After that was to run some of these codes on the converted data and see whether the charts make sense or not. Does it resonate with our understanding? Yeah, then it kind of made sense. Metformin is, we would, it's unsurprising to see that many people take metformin. So some validity checks along the way. It's impossible to screen through the entire database. So sampling was one. The other thing that we could probably also do is to recreate this entire thing. So recreate those charts on the unconverted data and see whether we get similar charts. That one we haven't done, but that is a bit more rigorous in making sure that what we are doing is correct along the way.
Thank you.
Yeah, I'd just like to add to that point. We just did a international consortium for some of the COVID-19 research, and these are exactly the problems, right? That we encounter between countries, between hospitals, between sites. Simple things like I saw earlier, you see something like augmentin, right? It's not a standard term in the OMOP CDM. So you have to go and look for, amoxicillin and clavulanic acid. And unfortunately, in Singapore, though we use RX norm, we have introduced modifications to them. So that's caused quite a number of drugs to not be aligned properly. So it would be great if you've done some validation for us to line up and make sure that the drugs are indeed mapped to the correct actual drug that was prescribed.
Yeah, drugs are always a problem. We have a similar challenge with labs as well. Lab test results are even more heterogeneous, especially if we do different. HbA1c is represented in so many different ways across the different hospitals. Some people call it glycated hemoglobin, some people call it glycosylated, some the percentage. It's anything under the sun. So harmonizing all these things, I think it's a very valuable effort to undertake ahead of time now. So, I guess we need people. So if you're interested to convert Singapore EMR data nationally, some of these mapping tables that draw, that take all the different representations of one lab and all map it to the common, the OMOP representation of HbA1c. That is a huge effort, but I think it would be so useful. It'll solve so many problems for so many research problems. Help us answer so many other questions that we can if we have this in place.
Okay, if you don't mind, please allow me to move on to our last item. At the last portion of our meeting this morning, we're going to have a casual and short panel discussion, which will be chaired by Dr. Niam, along with our panelists Paul Yo, and also Ming Si, the director from our Ministry of Health, Chief Health Scientist Office, and also Hui Zhen, the Senior Assistant Director from our Ministry of Health as well. So yeah, Dr. Niam, are you there?
Yeah, very much so. I've been listening. So thanks everybody for joining in this Sunday morning chapter discussion. I think we had quite an interesting debate as well as to talk about the different efforts at the different sites. So I suppose to sort of get this panel going, I think maybe I can ask from the other other panelists what they see the future of the use of OMOP CDM in Singapore. KJ, you want to have any comments on that?
I think it's a very important step, and I think having a common data model helps, in terms of the understanding of the data, especially between different institutions and countries. I think the challenge for me as more a clinician as opposed to a data scientist is where do I park it in the in the system architecture that I have? Is it where is it laid upon, and how do I pull together the resources to do the mapping? So I had almost wanted to ask Selva and Mengling, how what is it in them to do this with clinician scientists? I mean, in other words, it is almost quite a painful, and I wonder whether it's a thankless job. So I was curious how to make the argument to find the resources to do this mapping. These resources are not easy to come by. So I think for me, it's more a logistic issue. I can see the need. I want to do it. It's just a hideous amount of pain trying to get the resources to do it. So what we have done instead is that on an ad hoc basis, say for example for cardiology, for SynCloud data, it's mapped directly between institutions. Now whether or not the CDM, the mapping that we do is the equivalent of CDM, I don't know, because we never thought of it that way. Maybe there's some similarities, maybe there isn't, and maybe we have to remap everything to OMOP. I'm willing to do that because then it allows the data set to be compared with other data sets around the region. But that's just what I'm saying. So if in the absence of a common data model, people will just be mapping within small research groups or within different domains. But because it is very research specific, having a structural funding to do this is not necessarily easy.
Thanks for that, KK. I think that's a really important point, right? I just want to point out one nuance, right? I think the first step is, of course, getting everybody to use the same common data model. But even when they use the same common data model, as Sri has pointed out, right, one site might map the same drug to a different so-called definition on OMOP. So augmentin is a good example, right? So where one side might map it to the RX norm definition of amoxicillin and clavulanic acid. Another side might map it to yet another different vocabulary, and therein you're going to have problems still, right? Ideally, everybody should be perfectly mapped, and just based on our experience, it's just not possible to get 100% alignment from day one. So, which is why we have versions. So typically when we do mapping, we have mapping versions, and it's simple enough that when you update a version, everybody should rerun their analysis so that to see whether or not there's any drift based on the mapping. And I think it's fairly important to give some soft launch of your platform or your atlas, because people would take a bit of time, or researchers or clinicians take a bit of time to learn how to use it, and they may do some exploratory extractions in the first place. So I would say that we definitely need to take it a step at a time and give versions of mapping so that you give people time to be able to adapt to the correct mapping standard down the line. So I mean, at least that's what we have seen with our researchers. You never get it right from day one, yeah.
And yeah, since Hui Juan and Mr. Juan join us, probably we should give them more chances to share their thoughts as well.
Yep, Ming-Shi, you want to comment?
Hi, thanks for having us here. So I'm Ming-Shi, I'm from the MOH Chief Health Scientist Office, and I guess why we are interested in this really is, so the Chief Health Scientist Office is a new setup in MOH, really looking at how we can better facilitate translation of research, and also to really foster a more supporting environment to carry out translational research. And really for us, data, as with all of you, we know that is really the next bound when it comes to data-driven kind of healthcare. So one of the piece of work that we've started doing, and also getting a lot of good advice from both KK and Yam, is to set up a national data sharing platform that will basically enable from both the platform architecture point of view and also from a policy point of view, a environment in which researchers, policymakers, and even the industry can come together to share their data and be able to link and fuse different types of data in a safe and trusted manner. So we call that the trust platform. And of course, as you can imagine, a common data model will be extremely important for us to do so effectively. And so we've been trying to learn from people who has already done this yourselves, and we've also reached out to HSA's team to look at work that has already been undertaken to see how we can make this more efficient. And I mean, I was listening to KK's point, and I think this is one of the key challenges really is to not just the resources, but also the people to do the work, such that we're talking about across Singapore, all the willing and able data contributors, cohorts, the clinical data from MOH, and so on and so forth, and really having a central team of people as we envisage now under the trust platform to do this, go out, partner with the data contributors, and do this in a systematic manner. So this is one aspect of work that we are embarking on. And Hui Jen is from the analytics team in MOH, and the team is helping us to, look into the exact, precise way of how we're going to go down to doing so across all the cohorts that will be contributing data to trust. Yeah, Nova.
Yeah, thanks, Ming-Shi. Vijen, do you have any comments?
Okay, so I just want to add on to Ming-Shi's point, right? How we are going to achieve this is actually via the collaboration between our platform, MCDR, which is the MOH Consolidated Data Repository, and the trust. So because there are different types of data that is going to be available in trust, while the MCDR will be the data source for the trust platform. So what we are going to supply is really the clinical data, which we will then make it to be OMOP CDM compliant, which I would say it's going to be a challenge for us because this is the first time that we are consolidating all the data from different clusters at a national level. And we do see a variety of inputs from different source systems. So that's why we will need to spend a lot of effort in terms of how to map the data to become OMOP compliant. To me, there are really two aspects of this. The first one is the OMOP standard vocabulary, like what Dr. Niam mentioned just now. There are multiple vocabularies in OMOP, but in order to facilitate the collaboration among the researchers, there is a need to have a common vocabulary. For example, for diagnosis, whether we use ICD or SNOMED. Then for drugs, we know in the clusters, they have already adopted a Singapore Drugs Dictionary. Then how to map it to the OMOP standard. So all these, I think, there are mapping issues that we need to tackle. Then the second part is about the CDM. Internally in MCDR, actually we have different tiers of data modeling. The first tier, what we are envisaging is a more flexible data model, which is going to be able to serve different use cases, not only trust, but other data analytics use cases across MOH and also our clusters. After the first tier, then we can map that to the OMOP CDM, which we then can provide the CDM data model to trust. So I think by this different tiering, it allows us to have flexibility, but at the same time, we also allow the researchers, which are the users of trust, to have a common data model to be able to work on. Yeah, over.
Thank you for that, Hui Jen. I think that's very exciting. I'm certainly looking forward to having a common data model and we on a national platform. And certainly we want to utilize this platform as a Singapore OHDSI chapter to hopefully do some alignment in terms of the mapping. Of course, we've done quite a lot of work in the area, and we'll be happy to share some of these insights in terms of what happened when we do mapping. There are a lot of intricacies when it comes to mapping things, and some of which are even very specialty specific. So I think these are things that bear some consideration in terms of whether throughout the country we would have the same kind of mapping for the same terms. So I just got one question to the panelists, perhaps, which is when you look at mapping, of course, it's important that we try to map as universally as possible. But however, as KK pointed out earlier, there are research groups that, of course, do their own mappings and things like that. And I would say that they somewhat are the domain experts, right? I mean, they know exactly what they did, what they are doing in terms of their research. So here I have a question, maybe for the panelists to address, which is how can we bring together these disparate groups of researchers in terms of their mapping?
Just maybe I'll make a few points to that. It's a very difficult problem. I think if you're using retrospective data, through our various electronic health record systems, I think the first is socializing the notion that data capture has to be accurate. We have been doing ongoing audits of our data collection for diagnosis codes for billing purposes, and to our horror, a good number of patients who come in for bypass surgery don't even get bypass surgery coded. So I mean, that's bypass surgery, it's scary, right? So, and then because we have so many trainees come through with us, every 3 months we repeat the story, and at the beginning of every rotation, every heart disease is IHD, whether it's valve disease or chest pain or whatever, everything is ischemic heart disease. So the coding quality is very dependent on the ground. The second point I want to make in terms of research groups, depending on whether it is prospective or retrospective research, is that I think there probably needs to be institution and cluster level harmonization that can only occur very slowly, kind of like sharing the idea that there's this thing called QI and QA that is unique from research. The whole thing about EPIC training and all the other ideas that come with a particular domain needs to be filtered across to all the different research groups, and progressively it will occur. It just takes a very long time. And to the point that was made early on regarding the MCDR, I thought that you can do what the HSA does, and which is that you marshal the resources to do the mapping within MCDR as opposed to depend on the cluster, and then bounce it back and forth eventually, and hopefully after some time everybody maps the same way. But at the beginning, MCDR might have to do that painful mapping process. Thanks.
Yeah, thanks for sharing. Just to share in MOH, right? Our plan is also to set up a central team to do the data cleansing. But of course, we understand that the central team now, we don't have the right expertise in terms of the clinical background. So we do need help from all the clusters and those who have already done the mapping. I think we would need to learn from all you guys. Thank you.
Yeah, just make sure here. I think I'll just add a point. I mean, when we were conceptualizing trust and trying to look at how the data standards should be established, we were toying with the idea of, at least for the research data, right, bringing everything into trust and trying to do it there. But I think in the end we took the advice from Yam and from various people who has done it before, that really the contributors themselves are the ones who knows the data the best. So the model that we are adopting really is a collaborative type of model, where there is a central trust cleaning team that works alongside the data contributors. So both sides will be putting in some effort together to clean the data together. So the contributors will provide the domain knowledge, being the ones who understands what's the data provided, how it's been collected, and then the central trust team kind of have that harmonization across the different contributors that will eventually contribute to trust. So I think that's our model now, which we are adopting for the phase 1 of trust, and I think along the way we'll probably have to learn and iterate on this process. On Hui Zhen's point, I think where we think would be the most challenging would be because as you pointed out, every clinical area and every domain would probably have its own uniqueness to it. And I guess the question is, as we grow and expand trust beyond, say, the initial proof of concept contributors to other disease area, other domains, how to ensure that there is still consistency and uniformity across. And I guess that's where some of the learnings from other countries like the HDR UK, where they establish clinical networks of different disease areas and really leverage on the clinical partners and of course the researchers in all this. Is in a way it's like a hub and spoke kind of model where they identified clinical area champions would serve to support the central HDR UK team in ensuring consistency across all the disease areas as well as they do that. So that's one concept that we can think about. Yeah, over.
I actually have a question.
Yeah, go ahead, KK.
Do you think that when we do build these data models, audit is required?
Yeah. Okay, so this is one thing which and I have also been discussing about, because across the I think we need to have some form of assurance to know that the data that we are bringing in does have and meet certain of the kind of standards that we're talking about. So we think it's necessary, although we have not actually gotten down to looking at how exactly we're going to do so. Certainly for the next phase, I mean, for the POC, we probably won't be able to do so. But for the subsequent phases of trust, that's one thing we need to think about. And I think also useful to learn from all of you to look at how this is currently done. I heard the HSA's approach, where you do a sampling upfront and then draw learnings from that. But I guess as we expand beyond a specific disease area or target group and collecting data beyond the 3 years that was shown, probably a different kind of scalable model would need to be done to do that. Yeah.
Okay, Morning, you have any comments?
So I heard that there are a lot of discussion about the effort needed and the team needed and everything. So I believe we also mentioned earlier, I think everyone understands it's a non-trivial task. I think more importantly, it's not a one-off task neither. As I mentioned earlier, we learned that it's a very iterative task as we engage in more studies. Then we slowly uncover, I'll say, some bugs or some mismatch or mismapping of concepts or initial mistakes or incomplete mappings that are in the initial version. Then So it's an iterative process that we need continuous efforts to and continuous support to enhance it. And I think that that's the bit that everyone probably need to mentally prepare for. It's going to be a long journey. But the good news is that we are not alone, right? Selva is doing a very good job. Selva, while we initially start converting the data into OHDSI OMOP, Selva was very active on the forums asking questions. And the international forum folks are actually indeed very, very helpful on the forum. And actually not just on the forum. If you're proactive enough, you can actually even schedule meetings with all these experienced guys who have done many ETLs and mappings for various regions and various institutes, and they are very willing to spend time with us and share their experience and even help us to solve some of the issues we have. Probably they can't be too involved in like debugging and things like that, but then what I mean is that they're really committed to help. As far as we can share the detail, the more detail we can provide to them, the more detail advice they can give us. And I think the point is that although it's non-trivial task, requires continuous effort, but we are not into this together. And I think that's a good thing about OHDSI. As part of this symposium and early on the US symposium in October, actually there's a huge community around the world working on this together.
Okay.
Yeah, so just want to remind the team that there are many resources online that we can tap on to. Yeah. Niam, carry on.
Yeah, so I just want to mention that having worked with at least 2 international consortiums, I want to emphasize how important this work is, because if we get it right in Singapore, and we also set the tone for collaboration, then we can achieve great things, and we won't have the same kind of problems that everyone else has in the world, whether in the US or in the Europe, where we've seen the same problems, right? They can't even agree on things like age. I mean, age is such a simple thing, right? Like, you know, how old are you, right? So they argue over, oh, we must put age in 5-year bins or 10-year bins or things like that, because we are concerned about re-identification. And I think that's the kind of tangle we can get ourselves into if we don't agree here. I mean, if we agree here and we think far in terms of, you know, how our researchers and clinicians would use this data and facilitate them, we would solve problems at the very beginning, and that will impact literally hundreds of people down the line. Yeah.
On a slightly more governance point of view, and I ask this in lines of, for us to agree, not when I say us, I'm saying as a group, right? When we engage folks, how and who makes that kind of decision as to the data model? I mean, what kind of engagement should ministry do or go forth? Yam, on your side, you know, did you have to clear any forums to get people to agree? You know, because obviously, whenever we talk about meeting certain standards, folks may say, well, I prefer that standard, or we want to do that standard, but you know, I don't have any resources, so go ask ministry for money to do it, which I think doesn't make sense either. I think it has to, but it's a general question about ownership of the problem and how do we marshal the different stakeholders within our respective institutions.
Yeah, here I think we are in a formative stage, so that there's no formalized process, but I always go along the lines similar to you, KK, which is that we serve our clinicians and researchers. So we had numerous occasions where researchers have written to us and say that, hey, you know, we think this mapping is wrong because the numbers we found in our data, you know, in our clinical database and on the Atlas is not the same. Then we go and check it, and indeed they are right. So then we'll do the, you know, the kind of corrections to get it aligned. So we must realize that no matter which, whether it's a ministry level directive or things like that, in the end, right, who are we trying to serve, right? We are trying to serve our researchers and clinicians, which is, and they know the data the best, right? I mean, I would never know that I'm 10% off or 5% off the actual data set if they didn't tell me, right? So, and a lot of them are actually telling us, some of them are telling us what quantitatively they actually know how many patients they have. Some are qualitative. They say, oh, this doesn't seem right. Can you check? Then we will check, and then we'll find that actually there's a problem with the way you search the term, or there's actually a real mapping problem. So to answer that question, I think the key is that we should really have specialty groups who would say that, okay, this is the correct way of mapping something, and use that as the basis for hopefully a national consensus.
Yeah. No, so just to add on, that was exactly the approach that the HDR UK used, right? They formed a teamlets of so-called clinical leads or champions for each area to do so, and for them to make the recommendation, because they are actually the eventual users as well. And I think that's the most important point that you made, which is that we need to be clear who's going to be using the data eventually, and be doing that cleaning with the end game in mind. So I just since we're talking about this point, for the work that's already been ongoing, say with NUHS and other partners here, are there ways or approaches you think in which we can take this concretely forward, where different groups basically, whether formally or informally, right? We have a team of different people looking at different aspects of domains of data, and being then the ones who make a recommendation as to how we want to establish the standard for that particular domain or disease area, and then try to promulgate that across. I guess that's one question or suggestion, whether that will work. If we start off with that, at least for a small selected areas, then we grow from that area, may help us to at least concretely nail something down to move it forward. Yeah.
So may I suggest that this is the correct forum to use that approach, to have sort of teamlets or people who are specialized in things, or to assemble people who are, say, interested in diabetes to align their data models. I suppose I'm going to ask Selva to organize this, but I suppose we can take a lead on this, on maybe common disease things that we really want to get aligned, things like diabetes and hypertension.
For heart disease, I think for sure we are keen to do so, because there's really the SynCloud working group already has the general understanding, and within between NUHS and Heart Center, SingHealth, we have already at least aligned many of the terms, although I suspect they are not OMOP compliant. So it would be logical to do that, and at least for the agreements between the clusters is in place. So I think we'll be happy to volunteer, to be part of that. So yeah, so glad to do so. I think I emailed you guys already, so just to take the next step. Yeah.
We saw that. Thank you, KK.
Yeah. To facilitate this, I know it's my fault. I've been dragging my feet. But definitely in early January, we will launch the official website for our Singapore OHDSI chapter. And under this website, what I hear now is that we will create sort of sub pages for heart disease, cardiac disease, diabetes, and hypertension for the moment. And echo with Niam say that we hope that this can be a informal, and even later on can be a formal platform for us to join this effort together. Yeah.
Yeah, I agree. Thanks. Does anyone else have any comments for this panel? Questions for the panelists as well?
I just have one for the HSA folks. Thanks for a very nice discussion and sharing of the analysis. So I couldn't help but notice that metformin was the #1 first-line drug, right? But I was also curious to note that that a large proportion of patients started with Insulatard. Is that correct?
Hi, Prof. Yeah. So the insulin that was in the chart, right? Because the majority of the patients that we extracted were from the inpatient cohort. So
I see.
so we suspected that most of them are on the sliding scale. They're not actually insulin users per se. So that was one limitation with the data as well.
Yeah. I think that's actually where the clinician comes in, because when I saw that, I was like, that would not make sense to me. So so I at least you know that I was paying attention to your talk. So
thanks for pointing that out. Yeah, that's also something that, that's why we wanted to do more follow-on studies to also see whether in a sense to validate what we actually see, to see whether does it make sense on the ground.
Thank you.
Thank you.
Okay, thank you very much. I think if there are no further comments, I would like to bring this panel to a close, and I want to join Morning in thanking everyone for joining us on a beautiful Sunday morning to have a talk about OHDSI. I see great passion, but passion does not last beyond lunch, I think. So I hope that you guys have a great weekend, and we certainly look forward to forming those teamlets as well as having a greater engagement with our OMOP OHDSI community in Singapore. Morning.
Yeah, I echo everything what Niam say, and I'll say thank you to everyone again, especially of Yo, Ming Si, and Hui Jen. I know Ming Si has been working with Selva like until midnight last night trying to figure out how Microsoft Teams works. We'll probably like feed this back to Microsoft Teams and
the government laptops are just too secure. We couldn't do anything to it. Sorry.
Yeah. But to all our other participants as well, like Niam say, thank you very much for your time and joining us, and all the passions for this initiative. Really appreciate, and I feel very heartwarming for seeing that. If nothing else, let's wrap this up and please enjoy your Sunday lunch. Okay.
Thank you.
Have a good day.
Very much.
Thanks, everyone.
Everybody.
Thank you.
Bye.
Bye-bye.
Bye-bye. Keep in touch. Bye-bye. Bye-bye.